A geometric term that we'll focus on in this lesson is the point. Points show positions relevant to other points. Here are 4 points. They could represent locations such as your home, your child's school, where you work, and where you shop. We will name them points A, B, C, and point D. We generally speak about locations by using descriptions. For example, point A is your home located at 5678 Charles Avenue. Point B is Parkfield Elementary, where you drop off your child on your way to work. Point C, your work location, is the building across from a certain landmark, perhaps a government office. Point D is the Pine Hill Community Supermarket, where you shop on your return from work. Note the inconsistencies in our descriptions of locations. Sometimes addresses are used, cross streets, other times landmarks, or the name of a community. For consistency and to make this data valuable to anyone beyond our network of regular contacts, we need to present the data in a universal language, mathematics. If we're looking up the distance, for example, between 2 locations, we would be limited in what we could do with these data in their current form. But if we associate numerical values to the data, we can use it to represent precise location, which will allow us to perform operations on all these values. For instance, representing our location numerically enables us to calculate distance between each location. Let's see how this works by selecting a common point from which we could measure these 4 locations. Our common point will be here. To help with measurement, we'll use the Cartesian plane. Use the Cartesian plane, which is made up of two lines perpendicular to each other. You've seen this before. The 2 lines intersect at a common point, which is the origin, or simply 0. The line extending northward and southward, as you know, is the y-axis. And the line extending eastward and westward is the x-axis. As we count outward, the numbers increase from 0 to infinity. And 0 is a point to which we will associate points A, B, C, and D. Numberings on these lines are key to identify the exact location of our points. The measurements on these two lines, the x and y axes, can be increased by any increment we choose as long as the increments are consistent. For example, 0, 1, 2, 3, 4 eastward corresponds with 0, 1, 2, 3, 4 westward. And 0, 2, 4, 6 northward corresponds to 0, 2, 4, 6 southward. So if we increase the number by 1, 2, or 100, or any other number, we must maintain that pattern for the particular line. We have now created a graph. The graph helps us to calculate the distance between 2 points. Let us assign x and y values to each point. A is -1 to the left of the origin and -2 units below. So point A is -1, -2. Point B is 2 units to the right of the origin and 2 units below. So point B is 2, -2. Point C is 2 units to the right and 5 units above the origin. So point C is 2, 5. And the last point, point D, is 3 units to the right of the origin and 4 units above. So point D is 3, 4. We have matched a number on the x-axis to a number on the y-axis. That number set tells us the exact location of that point. Such a set is called the ordered pair. The number obtained from the x-axis is called the x-coordinate. In this case, -1, 2, 2, 3. Those are all x-coordinates. And likewise, the number obtained from the y-axis we call the y-coordinate. We have now transformed or converted our inconsistent word data into consistent numerical data. Data is bits of information, individual bits of information. In this case, it is the value given to the x or y coordinate. We have combined the x and y coordinates to obtain ordered pairs. Data in this context is valuable when we can perform mathematical operations on it to create information. For example, we can use the data to find the distance between each point or location. Some of us may be familiar with the distance formula from our studies in algebra. The sum of the distances between each point equals the total miles or kilometers for that route to and from work. We can use the total mileage as input for calculating the cost of fuel for any trip. That information helps us to forecast our weekly or monthly fuel cost. It all starts with the point, and then converting it to usable data, which in turn creates information.